Okay, welcome to the new video. So today we're going to discuss physics O levels 5054 paper 1 variant 1. Let's start with the paper. The length of the copper wire is labeled 0.5 meters and diameter is 0.5 millimeters. Which instruments are most suitable to measure accurately the length and the diameter of the wire? So since the length is 0.5 meters, so it is a meter rule which can measure this length, and the diameter is 0.5. Therefore, whenever you're going to use a wire, the diameter of the wire should be measured by the micrometer. Driver drives a car at a uniform velocity along the road. The driver sees a hazard and applies the brake. What is the car's motion as it moves through thinking distance and as it moves through the braking distance? Motion through thinking distance. Since at the thinking distance he is going to put his feet away from the accelerator and he will not apply the brake, so he'll be traveling with a uniform velocity, so B and A is wrong. But when he is traveling through a braking distance, it has to be deceleration, because at braking it slows down. The diagram represents the moon as it orbits around the earth. Which arrow represents the direction resultant force acting on the moon at the incident shore? We've gone through this multiple times. Whenever something is moving in a circle, the resultant force is always toward the center of circle, so that's it. The mass m of an object is related to its weight G, W, and gravitational field strength G. Which equation is this? W is equals to mg. So m is equals to W over G. The plastic cube of density rho is compressed so that its each side becomes one half of its original length. What is the new density of the material? So now, since cube's new length is 0.5, this previous formula of density was mass over L cube. Now we have 0.5 L times 0.5 L times 0.5 L. So it is going to be 0.625 L cube. And when I'm going to use this, now this is the new volume, right? Now when the volume was L cube, the density was P, right? And the mass is this. For the new density, mass over volume again. The mass we have calculated in our previous expression, this one, I'm going to put it here. The volume is 0.625 L cube. Is it 0.625? No, sorry, it's not 0.65. I'm not using calculator, so I'll have to use the calculator so that I can. Just 1 minute. Okay, there's a calculator here now. So it is 0.5 times 0.5 times 0.5, so it is 0.125. so pardon me for this, I need to rub this. This is 0.125, so 0.125. so L cube gets eliminated with L cube, and 1 divided by 0.25, 1 divided by 0.125 is going to give you the 8, so it will be 8p. The four glass objects have a square base of equal area, which object is the least stable? So for the least stable, the base area, since the base area of all the objects are equal, so what we need to do is we need to see that whose area is most uh, concentrated on the top, so that it becomes the least stable. For this, C is the right answer, because for B it is uniform, so it will be lying somewhere here. B base area is greater and the upper part is the smaller one, so it's a little lower than that. For C it is going to be a little upper. For D it's a very uniform one, so it's going to be in the center. So higher the center of mass, least the stable the object is. Initial pressure of the volume V1 of a fixed mass of a gas P1 is a P1. The gas expands at a constant temperature until it has a volume V2 and a pressure P2. This statement about the pressure and the volume of the gas is not correct. So pressure is measured in Newton per meter cube. No, it's not in meter cube, it's Newton per meter square. Pardon me for this. So that's A. Let's see why the other ones are wrong. Pressure multiplied by the volume is a constant. Yes, that is correct. It says not correct. Pressure is directly proportional to 1 over V. Yeah, that's also correct. The ratio of the volume V1 to V2 is equals to the ratio of P2 of P1. Yeah, that's also equal. Correct. So only A is incorrect. A stone falls at terminal velocity in the air. What is equal to the change in gravitational potential energy of the stone? So the change in kinetic energy, since it is traveling at a terminal velocity, so there is no change. Change in temperature of the stone, the friction between the stone and the air, the thermal energy produced. Since kinetic energy is not changing, so gravitational potential energy is changing into some other energy, which is thermal energy. The water in the river is used to turn turbine as the water flows downstream. How is this type of power source described? So it is hydroelectric, since it's related to water. A load is pulled by a rope attached to a motor. The resultant force exerted by the rope and the load is shown. The diagram, each diagram, the load moves in the direction of the force shown and takes 10 seconds to travel 1 meter. In which diagram does the motor work the greatest power? So power is equals to energy over time. Energy is equals to force into distance over time. Since these two are constant, so it is going to be dependable on the force. Greater the force, greater the power. So this has the greatest power force, so it is going to have a greatest power. Sorry, 12. Pardon me for this. S12. Greatest force, so greatest power. The total energy incident in 1 second on a group of solar panels is this. A group of solar panel converts this much energy into light energy and 120 joules of useful energy. So this much of light energy to one, right? What is the total surface area of the panel? What is the efficiency of the system? The first of all, efficiency is 120 over 720 into 100%. So from here, if we're going to calculate the efficiency, let's use our calculator. This is 12 divided by 72. This is 17%. So efficiency is 17%. And he says what is the surface area of the panels. So in 1 second, it says it gives this much per meter square. So since this is energy, this is power, force, this is pressure, energy over area. Let's see anything. So 120 joules in 1 meter square. So 720 joules in how many meters square? So when you cross multiply, you'll get 6. 1000 watt and 240 volt electrical devices switched on. How much will the energy? How much energy does it use in 5 minutes? So energy is equals to VIT, because VI comes from power. So 240. The problem is that I don't have a current, so we can use P is equal to VI for this. Its power is 1000 divided by 240, that is current. So I'm going to use, instead of current, as this. It was easy, it was already given power, so I would have used the power here. So leave it aside. So it is 1000 times 6 times 5. 1000 times 6 times 5. So that is 1000 times 60 times 5, sorry. So I'll have to do it again. 1000 times 60, because there are 60 seconds and 1 minute. I need to convert this 5 minutes into that. So this is a 300,000, right? So time has to be in seconds. A building has a wall made from a wood and steel. What describes the way in which the thermal energy is transferred through the walls? Conduction through the wood by the movement of the molecules through the wood only? No, that's not possible. Conduction through the metal by both vibration of particles and the movement of electrons through the steel? Yes. Conduction is done by the vibration and movement of the electrons. Conduction through the wood, that's not possible. Convection through the metal, that's not possible as well. A liquid column liquid column in a liquid in glass thermometer is 2 centimeter long at 2 degrees Celsius. The column expands by 10 centimeter when heated to 100 degrees Celsius. Measuring from P, how long is the liquid column at 30 degrees Celsius? So the unknown temperature can be measured as the length of unknown temperature minus length of ice point over length of steam point over length of ice point times 100. Since this unknown is 30, we need to find out this length. This is 2, ice point is given. This is total 12, because I need to start from here till here, that's 12 minus 2 into 100. So that's 10, that is going to go and multiply there, that's going to be 300. Hundred will go and divide here. Minus 2 will come and add up here. So that's 5. There is one problem here. From 0 to 100 it is given 10 centimeters. So yeah. In many applications, thermocouple is used to measure thermometer temperature instead of a liquid in glass thermometer. Which properties of thermocouple is a major advantage? its greater heat capacity, its smaller temperature range, quick response time. It is very sensitive. A liquid and glass thermometer consists of a bulb containing a liquid which expands into a thin capillary tube. The liquid in thermometer is replaced by the same volume of the different liquid that expands more for the same temperature rise. The length of the capillary tube remains the same. How does the new thermometer compares with the old thermometer? Okay, now since you can say the length of the capillary tube is same, but what has been replaced by that expands more for the same temperature rise. So it is going to be sensitive, but the range will be smaller because it will react more quickly, so it will rise quickly. But since it's going to rise quickly, therefore it's not going to cover a lot of range. What is the UL symbol and what is the unit of real heat capacity of the object? Mm, so heat capacity symbol is capital C, and since it's a heat capacity only, so it is energy per unit degree Celsius. Which row describes the arrangement of particles and the forces between the particles in a solid? Arrangement of particles is regular, so C and D is wrong, and the forces between the particles are very strong, so it's A wave in the sea collides with a cliff. The crest of the wave hits the cliff once every 6 seconds. The horizontal distance between the crest and the adjacent trough of the wave is 4.5 meter. What is the speed? Since the horizontal distance between crest and adjacent trough, so it means it is going to be like this is the horizontal distance, 4.5. To get a complete wave, we're going to add 4.5 into it so that we can get a wavelength of this. So the wavelength will be equals to 9 meters. Now we need to find out the speed of this. It says the crest of the wave hits away, so this is a time period given 6 seconds. So from there I'm going to get a frequency, so that's 6. So V is equals to F lambda, then we're going to apply this. Frequency is 1 by 6, wavelength is 9, so that is going to be 1.5. A sound wave refracts as it passes from air to the water. Which quality changes? So the frequency remains same, but speed and wavelength changes. An object is viewed through a thin converging lens. The diagram shows the path of the two rays from the top of an object. I right. How does the image compare to that of an object? Yes, it is a larger object and it is upright and it is virtual as well. Reason is because it is on the same side of the object, so it is going to be virtual. If you ever like want to check out if the image is forming on the other side of the lens somewhere here, that's going to be real, but since it's forming on the same side where the object is, so it is going to be virtual. A ray of light enters the prism as shown. Which row is correct? So which wave properties observed? Yes, there is a refraction as well and there is a dispersion as well. Frequency of the red light compared with the frequency of blue light. Red light has a greater wavelength but smaller frequency, so it is going to be C. Which waves are not the part of the electromagnetic spectrum? Ultrasounds are not the part of electromagnetic spectrum. Radio waves are, television signals are, UV is, because this is what a spectrum is. Gamma, X-rays, ultraviolet, visible, infrared, micro and radio. This is radio, this is micro and radio, this is UV, so ultrasound is not the part of it. A man stands between two tall buildings P and Q. He is 50 meters from P and 200 meters from Q. He sounds a horn. He hears the first echo from the building P. 1 second later he hears the second echo. What is the speed of the sound? Okay. So that's very easy. Like in 1 second later, if he first when he is going to hear the sound, this sound has traveled 100 meter, 50 meter here and 50 meter here, and when he hears the first echo, this sound would have traveled 100 meter. Now 1 second later is going to hear the sound of this building Q, so this will travel 100 meter more and then 200 back, so it's going to travel 300 meters in that 1 second. So 300 meters in 1 second, so that is going to be 300 meter per second. That's B. Sound travels different speeds in each of the three states. Material solid, which rows will sound travels faster? Okay. Sound travels greatest in solids. In solids, it has a speed somewhere around 2500 to 3000 meter per second. In liquid, it travels less than that of solid, so it's 1000 to 1500 somewhere. And in gases or in air, it is going to travel 300 to 350 meter per second. So this is the order. State in which it travels fastest is the solid. State in which travels slowest is the gas. Which one is the use of ultrasound? Ultrasound is not being used in fluorescent tubes, not in optical fibers, not sunbaths, so it's for cleaning jewelries. Which material is used for the core of electromagnets? So it should be a temporary magnet, and it should be a stronger magnet which should have a property so that it takes all the field lines through it. So that is iron. Two metal spheres are mounted on insulating stand. The sphere X is initially uncharged, sphere Y is initially positively charged. So Y is positive. Rod is held by insulating handle is placed in contact with this. What are the charges on X and Y after the rod is placed in contact with this? So whenever something is touching with the something, the same charge is being transferred to the other, so it should be a positively charged, and Y should also remain a positive charge. Induction only occurs when you do it from a distance. You keep a distance. If you would have kept a distance from the Y, and you should not have attached this metal rod, this would have become a negatively charged on one end, and positive charge would have gone to this end, and then through earth this would have been removed and it would have become a negatively charged. Which device involves use of static electrical charges? So computer hard disk, motor, photocopier, we've studied the use of electrostatic charges. Like for example, if you want to take a photocopy of this letter A, what he's going to do is he's going to make it a positively charged this letter where it is being printed, and the ink is negatively charged. The ink is thrown by the cartridge on this paper. It sticks where the charge is, and the rest of the paper becomes is like clean as it is. So you'll be getting A as a photocopied. So this charge uses the static electricity. Initially uncharged copper rod is placed in a uniform electric field. The rod is parallel to the field. Which diagram shows the charges induced in the on the rod? So it should always be like this. Field lines always comes from positive to negative, so it should be leaving positive and should be coming into the negative. So this one is correct. This one is wrong because it should not have one type of charge. So C is opposite, so D is the right answer. The diagram shows electric circuit diagram how the charge of an electron and direction of electron flows through the resistor. Direction of electron flow is from negative to positive. Current is from positive to negative. Okay, so it is from Y to X. So Y to X, Y to X. So these are two wrong, and the charge is negative. So that's B. When a flash on a lamp is used, the charge of 1.5 coulombs flows through this time. The average voltage across the flash lamp is this. What is the electrical energy supplied? Okay, electrical energy. Energy is equals to W is equal to VQ. V is 3600. Q is 1.6, 1.5, sorry. So that's going to be giving you 5400. So either it's C or D. And for the electricity, power P is equals to VI. Since we don't have I, we have instead of I as, we can find out I from Q over T, 1.5 over 0.003. So your voltage is given as 3600 into 1.5 times 0.003. So we're going to use the calculator for this. 3600 times 1.5 divided by 0.003. So that is 1.8 into 10 is per 6 D. What is a unit of potential difference, or which measuring instrument is used to measure potential difference? That's very easy. Ampere is of current, it is volt. So either C or D is correct, and voltmeter is the device that is going to measure the volt. The diagram shows the four circuits. Each circuit contains three resistors of 100 ohm. Which circuit has the smallest total resistance? So we calculate this resistance, these two, this is going to be 1 over 100 plus 1 over 100 for these parallel ones. So that is 100 over 2, and then I am going to take reciprocal because it is 1 over R. For R I am going to take this as 50 ohms, and then this becomes 50 and this is 100, so they are in series now. So it is going to be 150 ohms of resistance for A. This one all series, so that's going to be adding all the three resistances, so that is 300. These one are all three in parallel, so 1 over 100 plus 1 over 100 plus 1 over 100, that would have given you 100 over 3, 1 over R. Then for R it is going to be 100 over 3, so that is 33.3 ohms. For this one, this is 200, this is 100, so 1 over 200 plus 1 over 100, so that is 3 over 200, that is equals to, again like a reciprocal of that, so that's 66 points. So it is the one with the series B. Sorry, it says smallest, not the greatest, so it is going to be C, smallest one. 35 a metal kettle is plugged into the main socket. The plug contains a suitable fuse. The kettle's cable is damaged and fuse blows. Why does the fuse blows? The bare earth wire in the cable touches the bare live wire. Yes, that can be one of the possibility. Yes. Metal casing cable touches the bare earth wire. No, that has nothing to do with that. That's already touched with that. Bare neutral wire has nothing to do. The live wire breaks without touching. No, that's wrong. It is becoming short circuit as live wire touches the earth wire and the current is now flowing into the earth, and since the resistance is minimum now, so more current will flow, which is going to blow the fuse. As the magnet moves into the coil wire shown, there is a small positive reading on the sensitivity meter. Which changes must increase the size of the reading. So moving the opposite poles into the coil, that does not changes the size. That does affect the direction. Pulling the magnet out of the coil, that has nothing to do with that. Pushing the magnet faster, yes, that can be. Unwinding some of the wire, oh, more turns is going to increase it. The diagram shows a circuit of the model power lines of with two transformer and the lamp at the output. What is the input voltage? 10 turns, then 100 turns, then 200 turns, then 40 turns. So we need to find out input. So first of all, we'll find out the voltage here. So that is Vp over Vs is equals to Np over Ns. I'm going to take this as a primary and this is secondary for this. So voltage of secondary is 24, voltage of primary we need to know, number of turns of primary is 200, this is number of turns of secondary coil is 40, 120 volts. Then when number of turns are 100, now this one will become a secondary and this will become a primary. So number of turns of primary coil will be 200, number of turns of secondary coil will be 100, number of turns of primary voltage of primary coil we need to know, voltage of secondary coil we got 120 right now. Oh sorry, primary is 100 and secondary is 200, because now we are taking this as secondary and this as primary. So Vp will be equals to 60 when you're going to calculate this. Now this becomes secondary and this becomes primary. So 10 over 100 is equals to Vp over 60. So Vp is equals to 6. Forty turns, 120 for 200 turns, 60 for that, and 6 for that. Okay, so in 38, electrical power is transmitted by the cables over the long distance at a high voltage. What are the effect of using high voltage transmission system? Power loss in the cable is low and the current in the cables is also low, because if we're going to use high voltage, we're going to decrease the current and we're going to get in return a less power loss. That's why it has been transmitted at higher voltages. The diagram shows a beam of electrons about to enter a magnetic field. In which direction does the deflection of electrons as? So you're going to use Fleming left hand rule. Field is into the page, so the index finger will point out somewhere opposite to this electrons, and your not index, this is middle. The index should go inside into the page and the thumb will point out the downwards. If you see that, it's going to go downwards, so down the page. Most alpha particles passes straight through the thin gold sheet from this Geiger-Marsden experiment. Few are deflected. What can be deduced? There is the nucleus is very small. Yes, that can be one of the deduction. Nucleus has no charge, it has a charge. Electrons surround the nucleus that's not deduction. Electrons have negative charge, that's not deduction, so it is A. So that's it. Hope you got the concept. If there is any mistake, since we're doing it live, so please pardon me for that. See you in the next video. Bye bye.